How will we transform the function t? That's what we're going to do next here. Laplace transform of just a nice linear function, f of t equals t. Let's transform it to produce a new function, capital F, that will actually be a function of s. You'll see why later. Let's see what that transformation would look like. So, to get our f of s, to get our Laplace transform of t, we're going to have to integrate from 0 to infinity, e to the negative st times t. Now that is the Laplace transform. We go from 0 to infinity and we integrate e to the negative st every time times whatever function you want to transform. We want to transform the function t. Now, from Calc 2, you might recall this is a beautiful application of integration by parts. And I hope your Calc 2 instructor shared with you integration by parts using tables. It would look something like this. On the left side, take the polynomial function. Take the derivative. Take the derivative. Take your exponential function. Find the antiderivative. Let's see. The antiderivative of e to the negative stuff is e to the negative stuff. But the derivative by the chain rule would have produced a negative s that ain't there, so I need to kill that negative s. And then antiderivative again would be another e to the negative st. We have to kill the negative s again, which would make that a positive 1 over s squared. I hope your anti-differentiation skills are sharp. And then tic-tac-toe is how this works. We go this times this times this, plus, minus. So this times this positive, this times this minus. So this integral would look like the following. We would have t times a negative 1 over s e to the stuff times a positive. So it's going to be a negative 1 over s t e to the minus st. And then it's this times a negative. So it's going to be a negative 1 times 1 over s squared e to the minus st. And we're going to evaluate that from 0 to infinity. Let's see what happens. Now, you might kind of get a little insight, if you haven't already, as to why Laplace used this particular transform, e to the negative st. As t goes to infinity, e to the negative infinity, this whole thing just tends towards 0, as does this. And so, as t goes off to infinity, 0 minus 0, we get a 0. Minus, like a 0 in for t. Now, if you plug a 0 in for t here, you're going to get the negative 1 over s times 0 e to the 0. E to the 0 is 1, times 0 is 0, times 0. And then minus, what happens here, e to the 0 is 1, so it's just going to be 1 over s squared. So all this boils down to, and there it is, the function capital F of s, that is the Laplace transform of just the linear function t, is just 1 over s squared. Now, you might wonder, what if we had some constant times t? What if our function was some constant times t? Well, you know that constants can just get pulled out front, so it'd be some constant times all of this, and so it would just be some constant times all of that. So constant multipliers, because we're at the heart of this Laplace transform is an integral, constant multipliers can just get pulled out front. So the way we're going to express that later is if we had the Laplace transform of, say, 3t. What we're really going to do is just take 3 times the Laplace transform of t. And we know that the Laplace transform of t is 1 over s squared, so it's going to be 3 times 1 over s squared. That's kind of how this thing's going to roll. So we're going to kind of focus on not constant multipliers. We're going to focus on t, we'll go to t squared, t cubed, etc. We'll do e to the t, we'll do sine of t, and you know multipliers will just kind of be multipliers, you'll see. All right, there you go.